Even if we now know that our universe is filled with expanses of cold, dark nothingness that no one could have foreseen, there is still something disconcerting about the vastness of space. Because of this, it's no wonder that the positive aspects of life get more of our attention. We must, however, stare into nothingness if we are to gain a full understanding of the cosmos. Hello everyone, welcome back to The Future Space, where we bring you the most recent news about scientists' new terrifying discoveries in the universe. But before we begin, make sure you subscribe to our channel and click the bell icon so you don't miss any of our amazing videos. And let's begin. Our finest understanding of the cosmos may come from emptiness. In its search for cosmic voids, NASA has made a crucial discovery. The void that spans 330 million light years and is essentially empty but contains a wealth of information. Let's have a look. On a clear night, you'll be able to view the stars no matter where you are in the world. Skywatchers who live in a distant region can see these stars at their most vibrant and spread over the sky. As a result, you may be perplexed as to what the emptiness is that is so often referenced, but which is obscure to the human sight. For some years, astronomers have been aware of this void due to the use of telescopes. Stars that are not yet old or fresh have been found in the area where the emptiness appears to be. Because of this, astronomers will have to reevaluate the way stars are distributed through galaxies. The Milky Way is home to between 100 billion to 400 billion stars, and our Sun is one of them. There are approximately 26,000 light-years between Earth and the Milky Way. Cepheid pulsating stars are used by astronomers to study the galaxy's stellar distribution. Cepheid's pulsation patterns can be compared to the brightness of our stars to estimate their redshift and distance from us. It has also been proved that the galaxy shape is twisted, yet so far everything appears to be as it should be. Astronomers' Cepheid stars can be found within a radius of 150 light-years from the galaxy's nucleus. Cepheids are absent from a vast area 8,000 light-years out from the galaxy's core. To see stars, you have to peer through a lot of interstellar dust, which can make it difficult to find them. To make up for these shortfalls, the researchers turned to near-infrared light for scans. Giuseppe Bono, a member of the research team, believes that the current results show that there has been no substantial star creation in this vast region over hundreds of millions of years. While Bono's appraisal of the scans is acceptable, the question of why no stars have formed in this region, and if they have, what happened to them, remains unresolved. Those dimensions of time and space are distinct. However, because we lack the scientific machinery necessary to analyze spatial and temporal aberrations, it's likely that we would have found the distortion if we had more powerful instruments and had been looking for it specifically. We may never be able to identify spatial distortions because our senses lack the sensitivity to do so. Regardless of whether we can see it from our backyards, if there is some sort of blob of dark matter or some antimatter generating mechanism that prevents or cancels the formation of the Cepheids, we know our technology is unlikely to pick up the unknown. Disturbingly, the notion that there is an emptiness in space without any stars remains. While a more rational reason may exist, it remains a mystery right now. Fear of the unknown, in the words of Yvonne Chouinard, is the greatest of all fears, owing to its enormous size and mysterious vibe. Our greatest fear is of the unknown. The night sky holds a number of other enigmas that researchers are working to unravel. The Boots Void, or the Great Nothing, is a void that lies beyond our galaxy and is rightly called the Boots Void. A large spherical region of space with very few galaxies explains this. Consistent with Lambda CDM, it's a huge void in the cosmos, and one of its most significant. Cosmic theory suggests that the universe's dark matter, dark energy, and ordinary stuff are all linked to one another near the constellation's Boot. Plowman in the northern sky has a hole in the heart of the universe. These 250 million light-years are regarded as a vacuum and are all nearly empty of stuff. It is possible to locate the Milky Way in a region of the same size as the Milky Way. The Boots empty, on the other hand, has only 60. As a result, the cosmos seems dark and vacuum when viewed from the galaxy's center. The emptiness of the Boot is supposed to be the result of several voids merging into a single final nothingness. The other galaxies are located in a cylindrical zone in the heart of the emptiness. This makes it plausible, given that the other holes were likely spherical shapes with the capacity to join together. It's like the outer edges of a city and the inner core of an unexplored void are suburbia and wilderness, respectively. However, an atlas isn't complete without more than just cities and roads. The map is incomplete without the empty spaces in between. Our cosmic fabric is being gradually deconstructed by scientists who are exploring farther and deeper into emptiness, revealing new and darker forces. We live in a dark universe in which 80% of the matter doesn't emit or absorb any light. Due to their gravitational attraction to atoms, the visible stuff of the universe, such as the sun, gas, and dust, reflects the distribution of dark matter that lies beneath it. In places where galaxies are the densest, dark matter is most concentrated. If galaxies are absent or virtually absent, dark matter should be abundant. Galaxies are situated in huge, shallow troughs in the dispersion of dark matter. The Empire State Building is the same height and footprint as a regular galaxy, while a medium-sized vacuum is 3 feet deep and 3 times the area of Manhattan. We can only gain a sense of the vastness and emptiness of these regions by collecting measurements in the key third dimension, which can be used as a proxy for density. Another type of darkness, known as dark energy, can be discovered by studying voids. It is the cause of the acceleration of the expansion of the cosmos, as well as the increasing size and number of voids. For the purpose of identifying this force, it would be beneficial to take measurements of the distribution of void sizes and profile forms. This means that voids, for all their emptiness, contain an abundance of possibility. When it comes to finding emptiness in the vastness of space, there's just one problem. Before Robert Kirshner and his colleagues in 1981, no one had ever seen the enormous huge empty. There are many galaxies in the foreground and background that obscure the vastness of a void. Scientific knowledge of voids extends beyond their mere existence. Researchers are eager to learn more about the size and distribution of these mysterious entities. General relativity predicts this. Thus, scientists are depending on gravitational forces to achieve this goal. According to Clampett, all matter and energy produce gravitational forces, which in turn affect the path of light. The familiar effects of a glass lens or prism are similar to the gravitational deflection of light by mass, although it is far more difficult to see. When the matter is dense, strong gravitational lensing occurs, resulting in striking multiple distorted images of distant objects. This phenomenon, known as weak lensing, occurs when the density of matter is so low that light is twisted, galaxies are amplified, and other new modifications are discovered that require a thorough examination to find holes. Thus, voids will play an important part in our understanding of both astronomy and the cosmos. In the far future, as a result of dark energy, the cosmos will be more empty than not. There will be only a few specks of light left as the vast interstellar network disintegrates. It won't be nothingness. That's the exception in a few billion years or so. And that's for today's video. We sincerely hope you enjoyed the video. If so, give it a like and share it with your friends and family. Let us know if you have any questions or comments in the section below. Don't forget to subscribe to our YouTube channel to see more of our incredible videos. You can also watch our other videos that have been specially selected for you. Look forward to seeing you in the next video.